This is the second lecture video for chemical formulas, reactions, and stoichiometry. In this section, we are going to discuss chemical changes and reactions, chemical equations, how to balance them, as well as reaction types. Let's begin with some of the basics. A chemical reaction is defined as a chemical change when substances combine or rearrange into something new. All reactions have two parts, reactants and products. The reactants are found on the left side of the arrow in a reaction, and the products are found on the right side of the arrow. Your reactants are like your ingredients, and your products are products, or results. We always go reactant to product, that's what the R to P stands for, and atoms are not created nor destroyed, so we're going to have to balance our equations out. There's a variety of symbols that are used in chemical reactions. The arrow usually stands for yields, or forms, or produces. The plus sign stands for the word and, or reacts with. You'll also often see states of matter in reactions. S, L, and G stand for solid, liquid, and gas. AQ stands for aqueous, aqueous meaning in water. And some reactions even have a triangle that is part of their reaction scheme, and that stands for whether heat is being added or released. Continuing our basic study of what chemical reactions are, there's a variety of ways to write out a chemical reaction. It can be written in the form of a sentence. Copper reacts with chlorine to form copper 2 chloride. This should not be a struggle for you because we have covered how to name and write chemical formulas. It is expected that you can still do that at this point and for the remainder of the semester. You can write it as a word equation, as you can see, copper plus chlorine, the arrow, copper 2 chloride, or as an actual chemical equation, the chemical symbols from the periodic table. So Cu plus Cl2 makes CuCl2. This is the way we will most likely be using throughout the semester. We have something called diatomic elements. You'll notice that from the word equation it said chlorine. It didn't say dichlorine. It didn't say anything about needing two. However, we put 2 Cl's in our reaction. The reason for that is because there are certain elements on the table that are diatomic. They are all nonmetals. They are known as the diatomic 7. There are 7 of them. They start at element number 7, nitrogen, and they make a 7 on the periodic table. So they're NOFClBri as well as H. What these are is if you see something say just chlorine or just oxygen or just nitrogen by itself, it's going to be N2 or Cl2 or H2, so on and so forth. Let's do an example sentence into a chemical equation that we would then, in essence, be able to balance later on. So here's our example. It says solid iron 3 sulfide reacts with gaseous hydrogen chloride to form aqueous iron 2 chloride and hydrogen sulfide gas. We're giving you the names, and you would have to write out the chemical formulas. So iron 3 sulfide, you're going to cross your charges, so you would get Fe2S3. You'd put an S because it tells you that it's a solid. It says reacts with, that's going to be a plus sign. Hydrogen chloride, H is plus 1, Cl is minus 1, so we get HCl, and we put the G. To form, that's our arrow. And then it says iron 2 chloride, so Fe plus 2, Cl minus 1. Cross your charges and you get this. And aqueous is AQ. And hydrogen sulfide gas. So hydrogen is plus 1, S is minus 2. And that would be the chemical equation that we would then balance. Please pause the video and try the 2 practice problems. Please review your answers to the 2 practice problems. Ensure that you properly crossed your charges and that you label things as they should be. Oxygen is diatomic, so it's O2. Everything else, you pretty much had to cross your charges for, or use your knowledge of covalent compounds. Next, we're going to talk about how to balance chemical equations. There are lots of different ways to do this and lots of different methods. Feel free to balance however you see fit. Okay, I will show you one way, and there are many others out there as well. So atoms have to be equal on both sides of the equation. We're going to first write the equation, then we're going to count up the atoms on each side. We're going to use trial and error and multiplication to make each side equal. A couple of hints there. H and O usually leave for last. Tend to be helpful if you start with the polyatomic ions. And then the number you multiplied by becomes the coefficient. It goes out front in the chemical equation. And then a couple of things to never do. You're never going to change a subscript. H2O and H2O2 are very different. And you would never add a coefficient in the middle of a chemical formula. It always has to go out front. So let's do a couple. So following my method that I described on the previous slide, I'm going to draw a line. I'm going to count up my atoms. I like to put a bracket around my compounds to remind myself that what I do to one, I have to do to the other. And then I just start balancing. So I have one carbon, so I appear to be good. But I have two O's on one side and one on the other. So I need to multiply by 2. Because that is bracketed together, the C also has to be multiplied by 2. And now I have to go back to the reactant side and multiply my C by 2. Now, both elements are happy. I have 2 carbons and 2 oxygens on each side, so I can add my coefficients. This is what the coefficient will be for carbon, so you would put a 2 out front. And again, since I multiplied by 2, I'm going to put the 2 out front here. It distributes to both elements. Please pause the video and try to just do the atom inventory for the second reaction there. Hopefully this is what you got, and now we're going to balance. You're going to notice that oxygen is in multiple places, so we're going to leave that for the end. Carbon, I have 1 on each side, so I appear to be good. I have 4 H's on one side and 2 on the other, so I need to multiply by 2. The bracket indicates that this is also times 2. Okay. So now my H's match. My total oxygens on each side have to be the same. So on this side I have 2 plus 2, which makes 4. So I have to come over here and multiply this by 2 so that it becomes a 4. And again, what I multiplied by becomes my coefficient. So I put a 2 here, and I put a 2 here. Okay. What I would like you to do is I would like you to pause the video and try the third problem there. Okay, and then we'll go over it together. So the correct answer is there in blue, and I have done my atom inventory. I like to start with my polyatomics, so my PO4, and over on this side I have 1 P and 4 O's, and on the other side I have 2 and 8. So I'm going to start first by multiplying this by 2. Sodium is part of that compound as well, so it also has to be multiplied by 2. So my P and my O are good to go. Now I've changed sodium. So I have 6 sodiums on the reactant side and only 1 on the product. So now I need to multiply by 6. I also have to multiply the Cl by 6 because it's in the same compound, same bracket. So now my NAs match, and now I have to deal with my Cls. I have 6 Cls on the product side, only 2 on the reactant side. So I multiply by 3. I'm going to also multiply iron by 3 because it's connected with the chlorine. And you'll notice that the irons also match. At this point, you should pause the video to try these additional practice problems. Here are the answers you should have gotten for the more balancing practice. Let's continue our study. The next section is all about reaction type. We're going to talk about 5 main types of reactions. The first one is combination, also known as synthesis. This is when 2 elements / compounds become one. You'll see that I have a couple of examples. Okay. And then you'll also notice that it says predict the products. So you're going to be responsible for identifying the reaction type and potentially predicting the products of the reaction. When we predict products, we always assume, for the most part, that we're creating things that are ionic. So I have to cross my charges. First example, I would have Mg. I'd use my periodic table, see that Mg has a +2 charge, and then I'd have nitrogen. I know nitrogen is -3, and so my product would be Mg3N2. Please pause the video and try the other two. Here are the 2 answers you should have gotten. You disregard the diatomic portion, so that 2 on the end, Cl and O, and just look at them as if they were ions, and then you cross your charges. Let's talk about decomposition. Decomposition is basically just the opposite of combination. So it's when a compound breaks down, right? When something decomposes in nature, it's breaking down. So we're going to go from 1 thing to 2, maybe 2 things to 3. It really depends on the reaction. Sometimes it'll break into 2 elements, as you can see here. And if there's a polyatomic, a lot of times instead it breaks into 2 compounds, as you can see here. So when you predict the products for these, you basically just separate them. So in water, the 2 components are H plus O, and then you just go back to your diatomics. And if they're diatomic, you add a 2. If they're not diatomic, you just leave them alone. So both of these are diatomic, so they would both require a 2. Please pause the video and try the other 2 examples there. And these are the answers you should have gotten for those 2 examples. Again, oxygen is diatomic, and the MgCO3 would end up very similar to the CaCO3. Let's continue our study. The next 2 types of reaction are single replacement and double replacement, abbreviated SR and DR. A single replacement reaction is a reaction where one element replaces another. So a metal with a metal or a nonmetal with a nonmetal. You can see that in the examples. Sodium was a metal, it replaced the other metal. F is a nonmetal, it replaced the nonmetal. Once again, as we predict these products, we're going to make the assumption that the product we produce is ionic. So we know in this first example that K is going to replace the Al. So Al is going to be alone. And then for the other 2 elements, I have to cross my charges. So K is +1, nitrogen is -3, so the product would be K3N. Please pause the video and try the other 2. It's important to remember that zinc has a +2 charge. Here are the answers you should have gotten. The H should have been replaced, and it's an H2 because it's diatomic. And then the zinc chloride should be ZnCl2 because zinc is +2 and Cl is -1. For the other example, the same thing should be true. H should be replaced to make H2, and then sodium, which is +1, should combine with the oxygen, which is -2, to make Na2O. We will pick up our study of reactions in the next video.